Good morning, I'm teacher from SMK Yokwan, Batu Gajah. My name is Chen Sangket. Today I'm going to prepare a video about modern physics under the chapter 7, quantum physics, with the topic 7.1, quantum theory of light. The learning standard I'm going to cover for today is describe quantum of energy, and the second will be explain wave-particle duality. Before we start with the quantum of energy, we will go through the quantum theory. What Max Planck able to found is that when he going to study the emission of light from the hot object, he able to observe the color of light. Actually, it will vary with temperature. From that, he suggests that actually the object do not continuously emit energy. Instead, it will just emit energy in a small packet form, or we say that in a small specific amount. Okay, so now we look at actually what is the quantum of energy. Max Planck, he said that actually energy released by the black body, it is in packet form, such that the smallest packet we name as a quantum, we name as one quantum. In order to calculate the energy of one quantum, we can use the formula E equal to hf, such that the h will be the Planck constant with the value of 6.63 multiplied with 10 power negative 34 joules second, and f will be the frequency of radiation. From this formula, actually the energy is directly proportional to the frequency of the light wave. Now we're going to relate the quantum of energy with the energy of a photon. Since we know that the photon will have a speed of light, so when we're going to relate with the formula E equal to hf, you will get another equation that is E equal to hc over lambda, such that h will be the Planck constant, f will be the frequency of the photon, or we name as the electromagnetic radiation, and c will be the speed of light in a vacuum with the value of 3 multiplied with 10 power 8 meter per second, and the wavelength will be, and the lambda will be the wavelength of the photon, or we call electromagnetic radiation. So what he able to conclude is that actually energy is quantized. Energy comes in discrete unit. Okay, now we look at the next part for this video, which is about the wave-particle duality. So this concept is being introduced by one of the French physicists named as the Louis de Broglie. He found that actually the particle, it will exhibit the phenomenon, the interference phenomenon, and also the diffraction phenomenon, just like what a wave able to do. Slowly, he proved that actually the particle, it can behave as a wave. So he speculated that actually the matter can behave as both particle and wave, just like a light, just like light. He proposed that the particle with a mass of m, that is moving at the speed of v, will have a wave nature that is consistent with a wavelength. Slowly, he introduced about the de Broglie wavelength. When he going to introduce the de Broglie wavelength, he going to relate between the formula of the particle, the formula of the momentum of particle, and the formula for the momentum of a wave, such that the momentum of particle, we have the formula P equal to mv, and the momentum for the wave, we have the formula P equal to h over lambda. When he going to combine both momentum together, he get his new formula we name as the de Broglie wavelength. The formula that is lambda equal to h over p or maybe lambda equal to h over mv. Okay. However, the object with a bigger mass, such that the mass is bigger than the atom, the characteristic of the wave cannot be seen, cannot be observed, because of the value of h is too small. That's why the de Broglie wavelength is too small. Just the small mass particle as the electron, it will show the wave property. It will show the wave property. So now we look at the result that prove that actually the particle, it will behave as the wave. So this one will be the classical result about the wave interference. And then during the 20th century, he discovered that actually the particle, it will behave like a wave, and then it will exhibit the interference. So what we able to see from this slide is that at the screen here, the light, which is a kind of particle, a beam of electron, it pass through two slits, and then it will produce a pattern of bright and dark fringe on the screen. And then from here we able to see that actually the light, it will behave as a wave. This is what he able to found. Okay, that's all for my video. Thank you.